All right, so let's take a look at another system of equations with three equations and three unknowns now. So again, I'm going to just try to solve this with Gauss-Jordan elimination. So I'm going to write my augmented matrix. So 1, 1, 1, 1, 3, minus 1, minus 1, 4, 1, 5, 5, negative 1. Okay, just writing all the coefficients down in my nice little augmented matrix. All right, so what can we do here? Well, I got a 1 already in the upper left-hand corner, so that's a good thing. And so I want zeros below it. So maybe the most logical thing to do would be to take row 2 and subtract 3 times row 1. Okay, we can start with that. And you can see if I make a little notes to myself, if I multiply this by negative 3, I'm just going to get all negative 3s. Negative 3, negative 3, negative 3. Okay, so I'm going to leave the first row alone, 1, 1, 1, 1. And then I'm just going to add negative 3 times row 1 to row 2. So I'm going to get 0. Negative 3 plus negative 1 is a negative 4. Again, I have negative 3 plus negative 1 is a negative 4. And then negative 3 plus 4 is a 1. Okay. Now, while I'm at it, why don't I just go ahead and subtract row 1 from row 3, because I can get a 0 in the lower left-hand column there as well. So I'm going to take row 3 and just subtract the original row 1. Okay, so 1 minus 1 is 0. 5 minus 1 is 4. 5 minus 1 is 4. And negative 1 minus 1 is a negative 2. All right, so there's my new augmented matrix. I've got the first column done, so let's work on the next column. So there I would like to have a 1 in the center, and I'd like to have zeros above and below it. Now I could divide by negative 4 here. I have a fraction is the only problem there, but and I'm seeing these two in the second column here, these two numbers match between the second column and the third column. So I think what I'll do is I'll just take row 3 and just add row 2 to it before I do anything else with row 2, because I can see a really easy way to get a 0 down in the third row, second column. Okay, so I'm not going to do anything with the first row, and I'm not going to do anything with the second row either. So minus 4, 1. And then I'm just going to add the second row to the third row. So 0 plus 0 is 0. 4 minus 4 is 0. 4 minus 4 is 0. And then I get a negative 1 here. Okay, there's my new augmented matrix. But again, I'm kind of at a sticking point. I can see right here, I'm kind of thinking about what these equations are telling me. Think about what these equations are telling you. This is telling you, this last row right here is telling you 0x plus 0y plus 0z equals minus 1, which can never be true. Never true. That is not true. Not true. Oops. Not true. That is not true. So we have an inconsistent system of equations, all right? Because this is telling us something that is not true. And so this system has no solution. Okay? That's the key thing. If you're working with your augmented matrix and you get a row that's telling you something that can never be true, then you can just stop right there and you're done, because that system can't have a solution. All right, let's take a look at another example. I'll meet you in the next video for that.